So let's talk double angle identities. So these are the double angle identities for sine, cosine, and tangent. So notice we call them double angle identities because we're looking at functions of 2 theta. And for the most part, we'll be given information about the angle theta. So we'll see examples like number 1, where we're given enough information about angle theta, or in this example, they're calling it x, but then we're asked to find exact values for the double angle. So let's take a look at this first example, and we'll talk through finding exact values for cosine, sine, and tangent of 2x, given cosine x is equal to negative 12 over 13, and we're told that that angle x terminates in quadrant 2. So we're drawing our triangle in quadrant 2. So this is for angle x, which is actually this, but we're going to base it on that reference angle. And consistently, we know that cosine is negative in quadrant 2, and this would be adjacent over hypotenuse. So this would be 12 over 13, and we can use Pythagorean theorem to find the other side. So just to save time, I'm going to go ahead and tell you it's 5, but we can do that by finding it using Pythagorean theorem like we have with the others. Okay, so now I can find any trig function of angle x. And let's start with finding an exact value for sine of 2x. So the formula or identity tells us that that's going to be 2 sine of x cosine of x. So I need both sine and cosine of x to find that exact value. So this will be 2 times sine of x, and we know sine is positive in quadrant 2, would be 5 over 13. And cosine of x, which is given, and we can also see on the triangle, would be negative 12 over 13. So now doing the multiplication, you can think of that as 12 over, or 2 over 1, if that makes it easier. This is going to be let's see, when we multiply across, this is going to give us negative 120 over 169. All right, let's take a look at cosine of 2x. So cosine 2x, similarly, let's go ahead and jot down. Notice for cosine, for cosine in this case, we actually have 3 different options. Again, they'll all take you to the same place. Since I already have sine and cosine, I'm just going to go ahead with the first one. So this is cosine squared x minus sine squared x. Okay, so cosine x, again, is negative 12 over 13. So this will be negative 12 over 13 squared minus sine squared x is 5 over 13. So 5 over 13 squared. So again, once I find these, we will end up with 119 over 169. And then finally, tangent of 2x. So we'll need 2 tangent x over 1 minus 2 tangent squared x. Okay, so tangent, again, will be negative, right? So tangent x will be negative, opposite over adjacent, so 5 over 12. So this will be 2 times negative 5 over 12, and then this is over 1 minus 2 times negative 5 over 12 squared. And this will turn out to be negative 120 over 119.